to the introduction.
So we have Mr. Pratik-Yuken from UCAN. He's received his BTech degree from Shivaji University, Maharashtra in mechanical engineering, and he has worked on several developmental projects. He has also registered a patent on his work regarding intelligent battery cooling system in EVs. And he has worked on real-world engineering challenges in domains of system design, product development, and analysis. So welcome to FPRD, Pratik.
Thank you so much.
And I think joining him is Mr. Anup Kulkarni. He's a mechanical engineer from IIT Delhi. He's done his BTech in 2024 and presently works as operations executive in. Can we have Anup's introduction on the screen, please? Yeah. So his projects include developing RAG chatbots for engineering standards, component database systems, and lean manufacturing implementations. He has research experience in discrete event simulation, and optimization algorithms, and he has been recognized as the WinStar with the WinStar Award for significant contributions to operational efficiency and cost reduction. So welcome Anup to FPRD. So over to you, Pratik and Anup.
Yeah, thank you so much for the introduction. Uh, Hello, everyone. I hope everyone is doing well. Uh, Before starting, let me tell that our presentation would be little different in the sense that we are not presenting any paper here, but this is sort of like an educational initiative where we are trying to talk about some new age, new trending topics and try to educate everyone here. I know many of us know about it. Many of us may not have much clear idea about it. So just to keep everyone in the same, at the same place, we are trying to have this session on AI and ML in fluid power. So let us all sit back and relax and enjoy this session. Um, Fine. AI ML in fluid power. How have we been introduced to AI till now? Just a second. Yeah. So how have we been introduced to AI till now? We have seen AI in mobile apps, right? AI-based smart cameras as they market it. We have seen a lot of AI-based Excel tools, a lot of YouTube ads running these days on AI-based Excel tools. We have seen AI-based industrial monitoring dashboards where they claim that it is using some AI model to give some results out of what the mechanical system is doing. Let us ask ourselves a question, is it really AI in action? Well, it is not. These are not AIs. These are not AIs. I mean, I have a phone with AI triple camera. This 8,000 phone. Do you think this 8,000 phone could be having AI in it? So this is all AI stamping that is going around. So what is AI? Let us ask that question. It's a very fundamental question. We need to know about it in order to inspect what is AI and what is not AI. So how do we define AI? Artificial intelligence is the field of computer science that focuses on building machines or softwares capable of performing tasks that normally require human intelligence. Here the term human intelligence is very important. And human intelligence comes with features such as learning from data, problem solving, logical and reasoning, all of it. So a true AI learns from data. If it doesn't learn, it is not AI straight away. Anything that is pre-programmed, anything if it is rule-based, it works on set frameworks, then it is not AI. Okay? So AI is something that learns by itself, it adapts over time. So you can refer to this checklist to get to know if it is an AI or not. Ask these three questions to yourself before concluding if something is AI or not. Does it learn from some experience? Does it change over time, or can it predict or classify or recognize? If the answer is no for these, it is not AI straight away. All right? Fine. So, to know more about AI, and since AI has been very much derived out of human intelligence, we need to know how human intelligence works. And for that, I have an illustration right here. There's a table of input and output. I have some input parameters and I have some output parameters. Uh, and there is a blank at the end. Can we try to fill this? What could be the last parameter here? I mean, it is 2 and then 4, 3, 9, 4, 16, 5, 25. 6 should be 36, I guess, right? How do we conclude this? Because we came to know by looking at this table that this is a y is equal to x square kind of format, where the inputs have been squared, and that is how we get the output. So let us try to introspect ourselves. How did we come to this conclusion? We followed 3 steps here. We observed the inputs and outputs. Then we derived a logic by seeing the pattern. And then we used this logic to predict the unknown. That is what we did, isn't it? Right. So for a robot, how robots have been working till now. If I give certain inputs to the robot, I always needed to give a logic to the robot. Here, output is equal to input square. And without the logic, the robot won't work. Only after I give the logic, it can generate some output, right? This is how the robots used to work. Now, if I give some other parameters to it, let's say here in this case apple, and I define some logic for it, as in pick if the object is round, pick if the object is red. My objective is to make this robot train for recognizing apples. So I give this, I give the apples, it will say yes, it is apple. But let's say I come across with apples which are green in color, then the robot won't be able to classify it as apple. It will fail in its task because the logic that I have given to you, given to the robot, was incomplete. So this brings a very essential question: how far can we go in providing logics? There should be a limit to that, and there is limit to it. We cannot keep giving lot of logics. There are n number of variables in that. So, inspired from the same thing where we cannot give logics for each and everything, people came up with an interesting thing where they said that, oh, let's not give logics to the robot. Instead, let's give the robot large number of inputs and output, and then let it derive the logic out of it. It is not we giving the logic, it is we asking the robot to derive some logic by seeing lot of patterns. And then use this logic to conclude some output by itself. Here, in this case, we had a first phase where the robot was trained, and the second phase where it got some output, which we call inference. So, in this case, we can see that the machine learns by itself by analyzing patterns out of the fed data. And hence, it is called as machine learning. So, this is what machine learning does. It takes lot of input and output, it derives its own logic, and then it uses that logic to derive further outputs for the given inputs. Machine learning is nothing different than AI. It's a sub-branch of AI. It is under the artificial intelligence. Fine. So let's talk about some more complexity. How does AI recognize complex features such as animal faces? I've taken an example, a second illustration for this. Let's say we have an unknown animal by the name of koala. How an AI will find it? For, for us to know how AI finds it, and since AI is closely related to human intelligence, let's see how humans think about it. So, if a koala's face is given to, let's say, these 3 guys, Mohan, Mike, and Nidhi, and the person asks them to evaluate which one is koala and which one is not, how this procedure happens? Well, we can break down this koala image into multiple sub-images and ask each one of them to identify each of these features and then rate the feature accordingly. So here in this case, each one of them was given, Mike was given the eyes of the koala to recognize, Mohan was given something else, each one of them were given something else, and with every new feature that they saw, they rated it and they gave a further conclusion. Now, a supervisor combined it all and final rating was given by the supervisor. Here in this case, 80%, 79% was the picture was matching as of koala. So this process, when we do in a clustered manner, let's say I have a bigger team now, I can sophisticate this process even more by having 2 people differentiating the koala in head and the body, and then further giving it to their teams to evaluate further. So if that cluster happens again, we can get a more accurate result out of it. This feature, this thing that is going on where parallel networks are used to conclude a certain result is very similar to how our human brain works. Our neural networks are no different. Our neural networks also work in the same way. So let's replace these people into small algorithms. And when we do that, we get something called as a neural network. This is called as a deep learning neural network, where we have a lot of hidden layers, we have some input, and it generates some output out of it. So with this, I present to you the third concept, deep learning. So deep learning is a machine learning technique that uses neural networks to learn from large amounts of data, mimicking human brain ability to recognize patterns and make decisions out of it. All right. How can we use this in our hydraulics, or is there any application in fluid domain? Well, there is. We have seen a lot of today itself. Um, and I'll try to show one in the form of preventive maintenance or predictive maintenance. So let's take an example of a pump. How can this pump possibly fail? Well, there are multiple reasons for it to fail, as I've mentioned here, contamination, overheating, and all. All we need to do is we need to mimic those into their equivalent physical parameters. And for each one of these physical parameters, for example, if there is some blockage or leakage, what physical parameter it would translate to? It would translate to difference in pressures, or the flow rate would reduce, something of that sort. So what we are going to do, we are going to assign sensors to capture all of these information, then feed this sensor information into a neural network, the one which we just saw. And then it can give amazing outputs such as anomalies detected, stop the pump. Pump efficiency decrease of 2% reported. Pump can fail in next 12 hours. Or possibility of plate wear damage. So basically, it becomes your chat GPT for this particular application, for the pump, once it gets enough training. So interesting, isn't it? And there are plenty of case studies already done in the same field. For example, this is one case study which is in the same line which I had explained just now. They are using some AI model, CNN, RNN, to evaluate the same thing. There are some other case studies, and by the way, this was the results that they took, where the train samples and the test samples were very closely related. So a lot of work is going on in this field. One more case study uses random forest for evaluating. It's a ML-based algorithm. Uh, One more case study uses digital twin of a hydraulic system. Now, digital twin is an exact replica in a virtual environment. You can see here there is a physical entity and a virtual entity. We can track everything live in real time. If any anomalies are detected, we can track that in virtual entity also. So these are all interesting applications and work going on in this field. All right, fine. Now moving on, I'll like to present you the fourth concept of the day, of our session. Please look at this image. This is an interface of a email, maybe Outlook or whatever that we are using. Uh, it says, "Hey Jason," and the next things are sort of auto-filled there. Have we all experienced this auto-filling, right? How does it do that? How does it know if, it has to say thanks for reaching out? Well, this is also AI in action. Well, how does AI recognize it? AI has studied a lot of patterns before. And what it does is, let's say I want to say good morning to somebody in the morning. So what it sees, okay, this is morning time, and I'm trying to message GOOD, good. The next likely word has to be morning, because it is morning time, and we generally do that. We wish good morning to somebody. This is how it comes to conclusion that the person is trying to say good morning. And the same logic is applied here when it is trying to fill this further. So when AI models do this interesting things to fill out the communication, it is called by the name of large language models, or LLMs. We must have heard about it before. LLMs. So ChatGPT, Gemini, Cloud are all LLM models. How does it work? I'll just give a short explanation about it. Let's say we give a prompt to the LLM saying, explain how a hydraulic pump works. Now it does it in 3 stages. First is to recognize words. It recognizes, okay, the user has inputted hydraulic, then pump, then works. So it recalls where it has seen the pattern before, right? Next, it predicts the next logical phrases. So since the user is telling something about works and pumps and hydraulics, it would complete in this way. A hydraulic pump converts mechanical energy into fluid flow. And it keeps doing it till it makes a sense out of it. Now again, please do remember that AI doesn't have any sense of what it is saying. It's a senseless robot. It is not intelligent. It's a perception that it is building that it is intelligent. It is not intelligent. It doesn't know anything about fluids. The way we understand, the way we feel physics, it doesn't feel. But it completes the sentences using the patterns that it has learned before. All right. This was about LLM. And to talk more about LLM, I have my friend with me from Wipro. They have deployed some projects on LLM in their and some live examples of LLM, which would be helpful for us to understand it in a deeper manner. So I head this over to Anup, uh, and that was all from my side. Thank you. Thank you, Anup. Yeah.
So, hi, good evening, everyone. Thank you, Pratik, firstly, for laying down the theoretical foundations of machine learning and artificial intelligence. So, I want to focus a bit on the applications of AI. We at Wipro are highly optimistic on AI and we want to ride the wave out. So, one of the most common complaints of business leaders in these past couple of years is that they're not seeing the payback from AI. So a lot of R&D investment is going into AI, but what is the business outcome? Are there real monetary gains that are being made? So the applications that I'll talk about, I'll first try to motivate it using a business problem, because I'm sure a lot of you in the room might be experiencing similar problems and may want to devise creative solutions. So the thing with AI or any even Web3 before that is that it gives you composable things that you can put together for a custom solution. So let's dive into it. So this is a tool that we had developed about 6 to 7 months ago. I was myself in charge of it. So I first, as I said, I want to lay out the business motivation. So the way we operate is that we have a highly custom business. The customer comes to us with a certain set of requirements. We have to give an RFQ. There is an entire cycle that happens, goes through R&D. There is a pre-bomb being made. There is a costing being done. And then finally, the RFQ may or may not convert. And throughout this cycle, there is a certain time period, the turnaround period. And the goal for any company really is to reduce this turnaround time as much as possible. And R&D being the most critical aspect out of all of these, because if any one of your component fails or if the customer technical team is not happy, then you have not really done your job well. So the business case was very clear that we want to bring down the RFQ turnaround time uh, while increasing the accuracy of the components that we have made. One unique advantage that we had was, since Wipro has been around for more than 40 years now in the business, we have a huge database of components that we have already used in the past. So we did not have a reliable way to reuse these components. And so combining these three objectives, the goal was very clear that we want our tool to enable component reuse and through that drive down costs. And we found through some heuristic-based analysis that about 60 to 70% components are more or less, similar across a lot of these RFQs. So why are we creating new drawings? Why are we identifying the new suppliers? Why are we taking 15 days to identify that we have already used some of these components in the past? So what this tool does is, and I will include a video of the demo as well, but what it does essentially is recommend you the best possible components. And then you can pick out whichever is the exact matching as per your requirements or the nearest matching one. And then you can make some small changes and yeah. So this is the tool. So this is an abstraction of the tool. I've just presented a black box here. What the tool does is accept, let's say, 6 or 7 important parameters. So for a hydraulic cylinder, these might be bore, rod diameter, type of cushioning, the mounting type, whether it's clevis or trunnion, the rod eye radius, and the piston diameter. And then we realize a lot of the components are some combination of these, and then the others, very minute ones, you may not even require at the RFQ stage. So if you're able to provide it with some confidence of about 90–95% the cost and the component requirement matching, then we are good to go. And then the output is these 7 critical components, and then a lot of seals or other auxiliary components are as a function of these main components. So this is a use case of k nearest neighbors algorithm. This is a traditional machine learning based algorithm. So I don't want to dive too deep into this, but the core premise of this algorithm is that uh, if let's say the weight of an apple is 500 grams and the price is let's say 100 rupees, just for an example, then the weight of an apple of 600 grams, the price is going to be very similar to, right? So it uses the similarity. Now there are some cases where there are huge fluctuations, there are discontinuities in the functions. So k nearest neighbors is not the right way to go, but we realized that for our use case, this works perfectly. So what it does is that the user essentially enters the parameters, the 6 or 7 parameters that I had shown earlier, based on the requirements of the customer. The app performs a search in our internal database, and it will return nearest and exactly matching components, 10 of these, if possible. The user, who's the designer in this case, can filter based on the date of recent modification. So the more recent a component is, the more we can be sure that the price in the system is accurate. We have suppliers for it. It has passed the design test. A design from, let's say, 2000s, which is still running, may have some quality issues. So we want it to be as up to date as possible. Then the designer can make minor modifications as a function of the exact requirement of the RFQ, and then the parts are finalized. So the downstream benefits of this is that preliminary design checks are done. You can go to the validation directly, and it expedites the time in the pre-bomb release. Proposal drawings are expedited, and hence the overall turnaround time, especially through R&D, which was a huge bottleneck, comes down. And then it is connected on the back end to a live database, which is updated dynamically. So every new drawing, every new component that is added is updated to the database. And if I update it now, and a search is made, let's say 10 seconds later, it's going to fetch the latest component as well. And overall, reuse is what we want, right? So it helps. So this is a demo of the tool. I hope it plays. Can we have the video to be played? No, not this one. This one.
We shall now see a demo of the Part Finder tool. This tool enables efficient retrieval of existing components, thereby allowing their reuse. It uses the k-nearest neighbors algorithm to predict most suitable components. Using a few dimensions, the user can pull the important components of cylinders across categories such as backhoe loaders, excavators, and material handling. This allows to reduce turnaround time for RFQs and enhance reuse, in turn driving down costs. It is integrated with the WinD design portal, which is used extensively by designers. The tool offers component retrieval based on 2 mounting types, clevis and trunnion. It requires 7 basic dimensions as inputs. The flag permits a range search. In essence, search in a plus or minus 10% interval around the input value. This allows us to fetch nearest matching components. The search is performed in seconds, and up to 10 most relevant options are displayed based on the R&D database, which is updated dynamically. Clicking on the tile opens the component drawing instantly. The drawing itself contains important details to expedite decision-making.
Right, so as you saw, so the Windy design portal that we briefly mentioned, so that is an internal tool which essentially stores all of these drawings. So this was also created in-house because we have more than about 30,000 drawings now, and a lot of version updates are there. There are ECNs released, you have to modify. So that is sort of our central database where we are trying to mount all of these tools. So the next application that we'll see is also mounted in that portal. So I hope the part finder demo was clear, right? So the next use case is much more standard in the way that, so Pratik ended his talk on LLMs. So I'm sure to some extent we all have use chatbots, LLMs, right? And we are surprised by their ability to be generally intelligent. So these LLMs can be thought of as an intelligent personal assistant, but they may not have the domain-specific knowledge that you're looking for. So now if I go on ChatGPT and try to ask it, this is my customer requirement, which is the Wipro internal standard that I should use to decide the material, the surface roughness, all of these things. ChatGPT will give me a very generic answer because it doesn't have access to our specific knowledge. So the idea is to supplement the generally intelligent LLMs with a store of knowledge. This is called as grounding in technical terms. So we wanted to, and this in turn serves multiple purpose, is that if you have a large store of knowledge which has been accumulated over many years, you can simply type your query and you can have a search which is performed specifically on your database. A lot of churn happens in the organization. We don't want information to remain with people who have left. We also want people who have newly joined. The knowledge transfer has to be smooth. So this tool also ends up helping in that. And overall, it helps saving a lot of time going through hundreds of documents for things which should have been very easily fetched, right? And the the special feature for this chatbot is that we are also able to supply references then and there as to where has the answer been fetched from, as you will see in the demo. And that helps to build trust. And also sometimes LLMs, as we all know, are probabilistic in nature. Though most of the times they are intelligent, they give good answers, but sometimes they may not go correctly. So we need some manual verification as well in case the intuition of the designer or the user says that something is wrong here. So how it works essentially is there is an input query. So here if you see the cloud on the left is an input query, which we usually end up typing in natural language. This is where the magic happens. So this is the database of our internal documents. And then it is stored by using a method called vectorization, where you essentially break down the documents into small chunks. You tokenize it. Tokenize it is basically storing the documents in form of numbers. Vectorization is mapping it into high dimensional spaces. And similarly, your query is also vectorized. So when it is vectorized and mapped into high dimensional spaces, it will fetch only the chunks which are relevant to our query, not random chunks. So this acts as the source of knowledge for your query. This goes into the intelligent LLM, and this can be ChatGPT, this can be Azure, this can be Claude, Gemini, whichever you want. So these are pre-trained models, so we don't mess up here. We don't play around here because this requires a lot of compute. This requires GPUs, some of you might have heard, to train. So we just supplement it with this knowledge. It is intelligent, it knows what to do with the knowledge and finds relevant documents using the query. And then you have a processing that is done, and then there is a response, right? So the costing, so a business use case, the business concern here is always how much cost will it call you, right? Because at the end of the day, a lot of AI use cases are incremental. These will not give you, at least the stage at which we are right now, this will not give you huge top line. This will not have huge top line effects. So to try to understand how the costing happens, so it's based on number of tokens roughly. So there are some input tokens that are going in. Input is these input as well as these inputs, and then there are some output tokens, and then you pay for the intelligence. So that is a combination of it which goes into the costing. So the process flow is something as like this. So the users enters a query in natural language. The tool fetches the relevant documents. The LLM being intelligent summarizes, gives a clear response. If the user has persisting questions or they want to verify, they have links to the references, and they can create a chain of thought. They can go deeper into that specific topic, and then the final response is generated. So all of this happens within a matter of seconds. This also allows version control of the documents because at the back end, the database which essentially goes here. So you can change the version of the documents directly. So sometimes when you have hundreds of documents, version controls becomes hard. So you can instantly replace the document here with the latest one. Reduces the upskilling time, obviously. And then it can be scaled across the organization for several use cases, including old presentations, drawings, if you want. So one use case that we had seen earlier was exactly creating a pre-bomb. So it was extracting some text from the drawings, identifying the pipings, all of that, and creating a bomb. So essentially that, so it can be scaled across use cases. And then we have a demo for that. So can you please play that?
Presenting Defined, our AI-powered chatbot, which provides technical information at your fingertips. This tool is built on the Azure ecosystem with GPT-4 model, which can answer queries related to complex information, grounded in hundreds of standards documents, in real time. It empowers designers with fast and reliable information and enhances productivity. Defined is integrated with the WinD design portal. The user can type in their question or few keywords for their requirement. A concise response is generated within seconds, saving countless hours spent in scavenging information manually. The references are available at the bottom, allowing the user to refer the actual documents on this very page. This serves as a valuable verification mechanism and source of detailed information. Overall, Defined, with its AI capabilities, makes life easier for all users.
So this has been specifically fine-tuned by us to... Yeah, I just quickly want to talk about challenges that we faced. So I think data, how good the data is the oil that runs in all of this machinery. If your data is not good, you will not be able to use any of these. So I think it's a push for all organizations present here to have good databases, coherent databases, digital ones preferably, so that you can apply these use cases. Thank you, and it's been a pleasure presenting. Thank you.
Can I request questions? Okay, could I just interject for a little bit? We've been working on some AI tools for a while. Now, the couple of things that usually come to mind. I'll give a very simplistic example. This is real AI in this nascent stages when AI didn't exist. Kid was asked, couldn't really identify in Hindi. So the teacher was teaching, there's a visual, and said, shows the Hindi alphabet fur, and says, what is it? The child says, fruit. Logically, everything right. That was AI, right? But you would say it's stupid, because first for ful and fur for fruit are the same. Okay, the image is the same. So that comes to the very last point that you mentioned about the data input. We are so obsessed with the output that we're missing the input, right?
Yes.
So a couple of things. There is research done today. There are authors who've never written books, but AI shows them as having written them. I think Jane Friedman, she's actually put forward, there's a whole list of books on Goodreads which she's never ever written, right? There are many things like that. So now that has all started with false data input. And that is so easily manipulated these days.
Yes.
As much of, hate to use the word, that you can put into the system and it'll generate that kind of stuff. So I think what is critical for us today is to focus on the input, right? Especially in the public domain. Now, since yours is in your personal domains, you know, you're quite good, you're fine with it, right? So I think that is something we all need to be mindful of, what we are feeding into the system. Every time we even ask a wrong question, it goes into the system. For everybody, I mean, this is totally out, it was not part of it, but I think it just triggered this in me. Recently, I saw a movie called Humans in the Loop. I don't know if any of you all have seen it. It is not on the internet. It is only in movie theaters for a reason. Please, if you get the time, see it. It's about AI and what it does in the cultural context, in the rural environment. They're using AI. So AI is culturally deficient. It is not equipped to take the cultural nuances. It is number fed. So number fed does not take into account individuals. So as much as I also so stupidly use AI all the time, I have come to a point where I ask whether AI is artificial intelligence or absolute insanity. I'm not sure. We will know in some time. But yes, just these were my 2 words, but the floor is open to everybody. Please shoot your questions to them.
It's just an add-on point. So artificial intelligence or insanity. So when you look under the hood of these LLMs, it's just numbers. It's purely numbers.
Absolutely numbers.
So
yeah.
these imitate. So it's imitation. It's not understanding. And once you understand and write a bit of code, it's just next token prediction. It's just predicting the next word, next word, next word, based on some probability distributions. And when you see the math, I have lost a lot of faith in AI's ability to understand culture, as you rightly pointed out, once you understand these works. But for specific things like these, it does work out pretty well.
As I said, internally, within closed systems,
Yes.
systems you can control, it works great. It'll work great for your organization, it'll work great for mine. But in the broader scheme of things, in society at a large, I am not sure it's the best tool around.
Yeah, just to add ma'am's point here, do you know how ChatGPT was deployed? Before deploying, by the way, ChatGPT learned everything out of internet. Internet is the biggest source library of information. And we know there is a lot of toxicity in the internet. So it learned and absorbed all those toxicity as well. So they had to deploy a team of humans to detoxify ChatGPT before commercializing it. So they used to ask questions to it. It used to give some answer which was not culturally apt, so they used to correct it. No, it is wrong. You should not say like this. That is how the training has been done, and part of it is because the information being fed to AI or any systems like this is where the flaw lies. If we feed good information, the output would be good. If it is toxic or it is bad in any sense, the output would be bad as well.
But there are, so adding on to that, so there are areas of AI called AI safety, where red teaming, jailbreaking, all of these are very well-known things. So in the biggest labs of the world, these are concerns that are being addressed with the utmost impatience as these topics merit. So these are being taken care of.
You know why the AI, unlike you? Because when they asked, please show the photograph of a pig, what came out was Trump's face.
I will not take much time, only 1 minute. I will just stand up and talk because it is a very serious matter. You have done a very good job because you are experts. I am not an expert, but I have to warn everybody. The AI is coming and it's come already. Artificial intelligence, one of the things that you must be very, very careful is whatever you are doing in the Google, search engine optimization, similar thing you have to do for AI, generative engine optimization. So all the people here who have got that either they are publishing papers or Fluid Power Society when they are putting in the website or this one or anywhere, we must be clear about our language and what we are to convey. Because that AI can go through your data and give it output to everybody he wants. Finally, what we will find is a lot of your data either is gone fully or misinterpreted and gone. For example, in Fluid Power Journal, I say some of the negative things that has come. It is not, not many people attended, this is the way, and we have to improve like that to tell my members. But AI intelligence, when it's flowing, if Fluid Power Society of India, suppose somebody gives a topic, there it will summarize saying that Fluid Power Society India had a lot of this one, but not much of attendance, it is there. This is the way it will come. So kindly, on all the people, please tell your sales manager, application manager, your librarian, and your publisher, whatever you are from today doing it, please see to it that there is somebody who is already going into your brain and then doing something and then reporting somewhere else. By the time we get enamored by all these things, oh, hey, I have learned this one, I have done this one. By the time your whole data will be gone and will be misinterpreted. Am I correct or not?
Yeah, absolutely.
Please, that is what I wanted to tell because I was only wondering. Last thing is, for example, future of hydraulics, I did AI, ChatGPT, and so on and so forth. That I started last year when it is not available in India. It was available only in my friend UK as well as in US for Intel and Google as well as one more company. I did future of hydraulics. I think I have reported in the council WhatsApp also came. But I made, that is interactive, you know that. Then I asked the question, I am not finding anything of hydraulics, but hydraulic oil nothing is there, the thing is there. What is it, I asked. So my friend immediately told. Then immediately another report came saying that hydraulic oil is the most important ingredient for future of hydraulics. And any development in hydraulics to see that all the components and other things will be prior, and also sustainability criterion for this one will be this one like that, another product. So you understand? Then what you want to go, and then you go on. So by either using AI or your own data going to AI, be careful. Thank you. Please excuse me for showing my ignorance.
No worries.
I am sorry that we all ate into the question answer time, but for the sake of brevity of time, we will conclude. I would request Ashwin Naidu to give, I do not know of another person who's as passionate and working so much on this field. So please, Ashwin, come and give them their mementos.